All right, so I'm reviewing for the progress check. You do not need to watch this whole video. Just go to parts where that'll help you out. When you start, here's a whole bunch of formulas. The only ones that are important are everything up to here. Yep, everything up to here you can use. They'll help you out. Everything afterward is going to be a little ridiculous, so don't be overwhelmed by how many formulas they give you. Just focus on these. Okay, so starting with the first one, we want to describe the transformations of fourth root of x and x to the fourth graph, and then match each function to its graph. If you're pretty good with transformations, you don't actually need to use a graphing calculator. You obviously can. So, for example, for the how would I put in this graph? So I'd go to y equals for the fourth root. Go to math. Scroll down to 5. Well, that's the xth root. Instead of x, you're going to put 4. I'm going to put x. And then you can graph it. Right? So that's what it's normally supposed to look like. So the fourth roots are either, what are these? You either got b or c for possible fourth roots. So if you take a look at the first one, that's the fourth root of x minus 3. Remember, if there's a minus 3 on the outside, that means it's gone down by 3. So the transformation that occurred here is a translation down by 3 units. Let's just say translation down 3. Which one has moved down 3? Well, clearly this one. 3 should be about there. Yeah. Most graphs like to center around 0, 0. Well, it's not 0, 0. It's moved down 3. So that's clearly B. This one's similar. It's just that now 3 is in parentheses. Not in parentheses, sorry. It's in the square root with the x. Remember, when you have a number with the x, it does things horizontally. And also, it does things the opposite of what you would expect. So instead of moving left 3, this is a translation right 3. Translation's right by 3. The only graph that matches the translation right by 3 is C right down here. So the endpoint has moved to 3 instead of being at 0, 0. So this is C. All right. Again, this one is transformation of x to the fourth graph. So what does the original x to the fourth graph look like? X to the power 4. Graph it. Right. Looks like kind of a skinnier parabola, which is that's kind of what it is. So x to the fourth. Well, this one's minus 3. Minus 3 with the x means it's a translation left by 3. No, sorry, not left, right. Translation right 3. I'm not thinking. Translation's right by 3. Right, which one has moved right 3? Clearly A. Process of elimination. This one is D. Plus 3 away from the x means I moved up 3. This is a translation. Translation up by 3. Translation up by 3. All right, first page, not too bad. All right, next, here we're solving for x, showing all of our work in the process. So I'm trying to solve for x, which means I need to get rid of everything that is not x. First thing I need to do is get rid of the thing that's most on the outside of x, most far away from x. That's that negative 3. Now, most of you would want to add. Nope, you would be dividing. That's because there's no symbol between 3 and the root. There's no plus or minus. So if there's no plus or minus, multiply, divide. These two cancel out. Cube root of x plus 5, bring that over. And 9 divided by negative 3 is just another negative 3. Great. Now I got to get rid of that cube root. We'll change colors. How do I get rid of a cube root? You cube both sides. Cube and cube roots cancel out. X plus 5 comes down. X plus 5 comes down. What is negative 3 to cube? Notice I put it in parentheses. Whenever you are doing an exponent of a negative number, put it in parentheses. Negative 3 cubed is negative 27. Yeah, this one, coincidentally, you'll get the same answer, but if you were to use an even exponent, it would definitely be wrong, so that is negative 27. All right, and last thing I do, plus 5, I use minus 5. 5 and 5 cancel, x equals negative 32. Absolutely lovely. All right, so just your general solving. All right, 3, it's asking to find the inverse. The first one's pretty bad. The second one's not too bad. So, when you're writing the inverse equation, what you first do is write out the steps of your original equation, reverse them, flip them all around, and then write the inverse. So, always start with the x. So what's the first thing that happened to x? You subtracted 4. After a subtraction of 4, there's a division by 3 going on. Most of you would go straight to that 5. Remember that 5 is on the outside. Can't deal with that yet. I got to cube root everything. It's been cube rooted. Then, oh, no, not the 5. It's been multiplied by negative 2. Finally, there's that minus 5. Now I got to invert this whole process. So if I'm taking the inverse, I got to go everything's got to go out of order. Instead of minus 5, which is the last thing we did, I start with plus 5. Instead of multiplying by negative 2, divide negative 2. Instead of cube root, you just cube the whole thing. I put a box there just so I don't forget what this 3 is. Instead of dividing by 3, I multiply by 3. And instead of subtracting 4, I add 4. When a problem gets this complicated, keeping your information nice and organized is the best way. Remember, this function is called f sub 1 of x. So we put f sub 1 inverse of x. There's a lot of weird little things going on here. So give yourself a space. Start with the x. Don't put it right next to the equal sign. First thing I do, add 5. Divide negative 2. Cube the whole thing, meaning put it in parentheses. Then cube it. Parentheses means it's putting it all in a group. Multiplying by 3. Multiplication usually goes in the front. I just put a 3 there. Finally, add 4. So here's my wonderful inverse. So keeping organized is the best way to not make a mistake here. All right, this one is a hideous inverse. What about the second one? That one's a lot more friendly. For this one, let's write out the steps. First thing I do to the x, always focus on the x. Well, I took the 4th root. And then I subtracted 3. All right, switch the order. Invert the entire thing. Instead of subtracting 3, I add 3. And instead of taking the 4th root, I go to the power of 4. And then I finally write my inverse function. So I write f2 inverse of x. Start with x. Give yourself some space. Add 3. Then power of 4. Right. There's my lovely inverse for this one. Yeah, this one's a lot easier. This one probably should have gone first. Inverses. Next. So I definitely should have given you a lot more space on this one. So a scientist starts with 100 bacteria in an experiment. So that you start with 100 bacteria. This would be represented by the point 0, 100. After 5 days, she discovers that the population has grown to 350. This is represented by the point 5, 350. So determine an equation for this bacteria population. Expressing using function notation, and show all of your work here. So yeah, I definitely should have given you a lot more space. This means I need to create an equation in the form of y equals ab to the power of x that matches through both of the plus points. Well, you know that when you have a 0 for the x value, your a value is 100. So I know for sure that a is 100. I know that a is 100, so I don't need to use this point anymore. What about this one? Well, remember, this is your x, this is your y. So plug this into the equation first. So y is 350. I'm going to write it off here. 350 equals ab to the x. Well, I found a. A is 100, right? So let's save some time and put it here. I don't know what b is. My x is 5. Great. Now I can solve for b. I just need to remove all of the stuff. So first thing I need to do is divide out that 100. Divide 100. Divide 100. All right, maybe change colors. Divide 100 on both sides. The hundreds cancel out. 350 divided by 100. I did this one before. It is 3.5, which equals b to the power of 5. Now, how do I get rid of that 5? Let me move here, ran out of space. So how do I get rid of that? I need to take the fifth root of both sides. So I'm going to take the fifth root, 3.5, the fifth root of b to the fifth. What happens? The 5 and the root cancel out. So that means the fifth root of 3.5 equals b. This is where your calculator will come in hand. So, as usual, go to math, scroll all the way down to the root right here, enter, change from answer, change that to fifth root. The fifth root, what is it again? 3.5. 1.2847. Depending on how you round, you will get very different answers from me. So don't panic if you see a number that's about like 200 off, because it will happen. I rounded it to 3 decimal places, because the AP exam likes 3 decimal places. But if you rounded it to, let's say, 2, or even used all the decimal places, your answer will be very different from mine. So, 1.285 should make my b value. Great, I know my a, I know my b. Put it into an equation. So y equals 100, 1.285 to the power of x. All right. Next, use the equation to find out population after 15 days. So plug in 15 and see what happens. Again, depending on your equation, you may have a completely different answer than mine. So y equals 100, 1.285, and instead of x, we are going to put 15. All right, this is where our lovely calculator comes in. So what is it again? Get this out of the way. 100, parentheses, 1.285, exponent of, there we go, 15. 4,300, I'm just going to round it up to 4,301 bacteria. So 4,301 bacteria. 4301. So, well, it's approximately 4,300.777, lucky. So, about 4301. Yep. I saw some other people with about 4,000 or 4,500, again, depending on the equation. All right. Oh, now we've got to find the average rate of change for the bacteria on the interval 1, 4. So there's the average rate of change formula, which is f of b minus f of a over b minus a. All right, so for that, we may want to rewrite this equation with f just to make it a little bit nicer. So I would use f of, in this case, it would be f of x equals 100, 1.285 to the x. I'm just putting f of x just so it's a little bit more obvious what to do. So f of b, well, remember, 1 is your a value, 4 is your b value. So, all right, let's do this then. The average rate of change is f of b. B is 4 minus f of 1, because that's a, divided by 4 minus 1. Now we need to actually find f of 4 and f of 1. So to do that, I'm just going to write it off to the side somewhere. F of 4 means I put in 4 into my equation instead of x. 100, 1.285 to the 4. I'm going to put that in the calculator, and that may give me some nice, well, it's not going to be nice, a pretty bad decimal. So I don't have to show it. I actually did this beforehand. That's 272.6 54. I also did it for f of 1. F of 1 is going to be 100 times 1.285 to the 1. Well, if it's to the exponent of 1, I don't need to write anything, right? This actually gives me a nice, pretty number, 128.5. All right, so plug in all this stuff. 272.654 minus 128.5 divided by 4 minus 1 is 3. Now we're going to find what this is. I already did this beforehand. No, I did not. I actually have to do this. 274.654 minus 128.5. That's 146.154. So 146.154. And then I need to divide that by 3. $48.718. All right, so that's our average rate of change here. That was messy. All right. For 5, we got to graph this. This is a square root function. You could do this by hand. To be honest, I would just second table it. I'm lazy. Put it in, square root. Where's that square root button? There you go. X minus 3. X minus 3. Make sure you move out of the square root plus 1. Right? Check to make sure it's good. Awesome. Graph it. See what it looks like. All right, it's kind of floating in midair. Second table, just to get where you start. Okay, error, error, doesn't exist, doesn't exist. First point is 3, 1, then 4, 2. 3, 1, 4, 2. 3, 1, 4, 2. If you do continue down the table, try to look for, 7, 3. There's our last beautiful point. 7, 3. And it would go this way. Remember, the graph doesn't exist for the number 3, so don't put any arrows here. Nothing should go here. Right? Graph and label. Be sure to identify the coordinates of at least 2 points on the graph. Right? So why don't you just label all of them? So that's 7, 3. This one is 4, 2. This last one is 3, 1. Yeah, just label all of them. All right, we got to find the domain of g of x. Domain is the x values. So look along the x-axis. This graph starts to exist after the number 3. So 3, infinity. Or always x is greater than or equal to 3. We're putting a bracket because there's no asymptote. That's an actual point. If there's a point there, we put a closed bracket. Range is vertical. All right, when does the graph start to exist? Nope. Yep, it starts to exist at the value of 1. 1, infinity, or y is greater or equal to 1. So think x is the domain is the x values, range is the y values. All right, is it increasing, decreasing, or neither? Graphs are read from left to right. It's going up, so it is decreasing because the numbers are going up, just increasing. All right, not bad. Moving along. The table represents a type of bacteria that doubles every 36 hours. A petri dish starts out with 12 of these bacteria. So you don't need to create an equation. They give you a table, so use it. All right. Oh, wonderful. It's another average rate of change problem. A is 2, B is 5, f of 5 minus f of 2 over 5 minus 2. All right, what is f of 5? Well, according to the table, it is 121. F of 2 is 30. Divided by 5 minus 2 is 3. 121 minus 30, that's 91 over 3. For this one, normally I would let you leave it as a fraction, but for these problems, I do want you to make it a decimal. It will be 30.333. Again, 3 decimal places, because AP exam likes 3 decimal places. The reason why I want a decimal is because in order to answer this question, it would be really awkward to use a fraction. All right, so what is this problem about? Bacteria is growing based on the number of days. So what this rate of change really means is bacteria grows by 30.333 per day. Well, not the whole time, but specifically between day 2 and day 5. So between day 2 and 5, this is the average rate of change. Between day 2 and 5, bacteria is growing at this rate per day. So in the context of this problem really just means give me a real world answer. Okay. Moving along down here. Goodbye, average rate of change. Oh, fun. All right, Martins and Gordons are saving for their family vacation. Martins have made a one-time deposit of $800 in a savings account. Okay, let's color code this. The Martins have made a one-time deposit of $800 in a savings account that earns 3% annual interest compounded weekly. All right, next. Gordons, other family, have also made a one-time deposit of $800 in a savings account that earns 2.5 annual interest compounded continuously. So look at the information and break it down. So first, A asks me to write the equation that represents the total of amount of money the Martins, red and blue, will have in their savings if there are no withdrawals or additional deposits. So there's a whole bunch of formulas. Well, this is a compound interest. So go back to the front of your page. Which one says compound interest? It's either P with the 1 plus R or with the E. This is compounded weekly. It says annual interest compounded weekly. That means there's 52 compoundings a year. It's because there's 52 weeks in a year. Let me just write that over here. 52 weeks in a year. That is why we're using 52. So according to the formula, let's call this formula M. Martin's put in 800 to start with. Now here's that 1 plus nonsense. 1 plus, what's the interest rate? That's 3%. Treat it like cents. 0.03. That's how you would write cent, right? Percent is, write it as a cent. Divided by 52, because I'm compounding it 52 times. Multiplied by 52, and then t. All right, so this is just your equation. Next one, write the equation that represents the money for Gordons. Gordons did a compounded continuously bank. So compounded continuously means I have to use the E formula. So G equals 800 times E, I don't need parentheses, E to the RT. That's 2.5. So don't get worried over the 0.5. Think if it was 2 cents, I'd put 0.02 and then put a 5 for that extra 5 to the T. All right? This equation, just to express which one we used. We specifically used this one. This is the equation that we used for the first one. The equation for the second one is part. Nope, I messed up. Actually, I messed up on all of these. There you go. So A equals that, and then A equals P E R T. Wait, that's what it should look like. So they each need to save $900 saved in order to afford their family vacation. Well, both families have enough money saved in 5 years to afford their family vacation. All right, so 5 years, just plug in 5 for both of them and see if it's more than 900. All right, this is a lovely calculator exercise. So starting with the Martins. M equals 800. 1 plus 0.03 over 52 to the 52 times 5 years. All right. All right. Let's put this joy into the calculator and see what it gives. 800. Nope, not 1,000. 800 parentheses 1 plus 0.03 divided by 52. Yep, to the power of 52 times 5. Just like that. Go. $929.43. Yeah, that's about enough. All right, so margins are good. So 929.43. All right, margins are in the clear. What about the Gordons? Other family. G equals, all right, 800 e to the 0.025. Instead of t, we're putting 5, because this is 5 years. Right? 800 second e to the, what is that? 0.025 parentheses 5. You can also just use the times button. 906. Okay, just made it. So 906.52. All right, do they have enough money? Yep, they absolutely do. Yep, they have enough. All right. Moving along. All right. Oh, this is my least favorite section. This is simplifying a lot of your exponent rules. For that first one, don't get overwhelmed trying to deal with all this one by one. Okay, what is 3 squared? 3 squared is 9. Deal with that first. Deal with the exponents and all that stuff. Times 2x squared. All right, well, what's 9 times 2? 18x squared. Cool. That's basically it. This is about as simplified as you can get. The issue with simplification problems is simplifying is very subjective. One person might consider something more simplified than another. All right, that's 9, 3 to the x, and 3. Do not just divide the 9 to the 3. They are currently stuck with these exponents. So what I'm actually going to do is I'm going to convert 9 into base 3. Can't I change 9 into 3 squared? It's because 3 squared is 9. Well, then what's left over? 3 to the x. Let's bring this down here. Now what am I going to do? Well, I changed 9 to 3 squared, because 3 squared is 9. I can actually multiply these exponents. 2 times 3x is 3 to the 6x over 3 to the x. Now, remember, when you are dividing exponents, what do I have to do? You need to subtract them. So that means it's really 3 to the 6x minus x. Well, what's 6x minus x? That is 5x. So it's 3 to the 5x. This is the most simplified version that we can get here. Okay, moving along down here. Let's deal with this. Okay, you could deal with the inside first, but remember, if you have an exponent outside and two things are being multiplied, you can distribute the exponents. As long as there's no plus, you can distribute the exponents. So 2 times 2 is 3 to the 4. And you're not adding, you're multiplying them. 2 times 2 is 4 as well. 3 to the 4th times x to the 4th. 3 to the 4th, you can do this in your calculator. That is 81 x to the 4th. All right, that one's nice. To be honest, I wouldn't really do anything to this one, but if you want to simplify it further, remember you can subtract it. So 7, subtracting the exponents, x cubed minus x, and there's not really anything else you can do. That's pretty much it. Yeah, what's with these and the easy ones? All right, 8 minus 3, oops. 8 minus 3 is just 5x to the 5th. Remember, when you are dividing exponents, dividing stuff with exponents in it, you're really subtracting them. All right, this is one of the ones where you've got to mess around with the numbers because they're not the same. You kind of want, with the division ones, you kind of want all of the bases to be the same. See, changed it to 3, oops, 3 and 3, 7 and 7. So let's make this 5 and 5. So 25 is 5 squared, parentheses, to save us. X to the power of 4. It's an exponent within an exponent. It's tricky. 5 to the x. All right. Well, we multiply 2 and x to the 4th. That's going to be 5 to the And there's not really anything I can do. It's just 2x to the fourth divided by 5 to the x. Then what does that make? Again, when you're dividing, subtract the exponents. 5 to the 2x to the fourth minus x. Yeah, so this has an exponent, this one doesn't. It's an exponent and an exponent, so you can't mix them together. Right, last page. Woo. Oh, great, another average rate of change problem. This is your A, this is your B. F of 8 minus f of 4 divided by 8 minus 4. We should be really good at this by now. Okay, what is f of 8? All right, if I go to point 8, it's not quite in the middle. It's almost like 75% up. So like the middle would be 15,000. I would estimate this as 15,500. Minus f of 4 is about in the middle, 1,000. It should be way more apparent when it comes to the actual assessment. 8 minus 4 is 4. You shouldn't need to estimate anything. 15,500 minus 1,000, that's going to be 14,500. Divided by 4, you get a lovely number of 3,625. All right, so this is bacteria. So interpret the answer in the context of this problem. So what does 3,624 mean? That means the cells grow at a rate of 3,625 per, it's not per hour. So the units are a little weird here. These are in quarter hours. So it seems like every 15 minutes. So per quarter hour. And again, this rate is not for the entire time. This is the rate between specifically the 4th and the 8th quarter hour. No? Between 4 and 8 quarter hours. Boom. All right, just average rate change all over again. All right. Oh, this is a fun one. So identify an exponential function whose graphs contain the points. Again, when you have 2 points, that means writing an equation that involves this. A, b to the power of x. Which equation in this format will fit these points? So this is your x and your y. This is also your x and your y. So write both of these equations. So what's the y value? 1/3, okay. Equals a b to the x. Well, x is 1, right? I don't really need to write anything, so I'll just leave it alone. What about 27? 27 equals ab to the power of 5. Again, I'm leaving this alone because it's just nothing. Right? Let me make that a 5. Now, great, I have 2 equations. How do I deal with both of them? I need to divide it. If I divide it, I'll cancel out the a's. Colors, 27 equals ab to the power of 5. Divide this by 1/3. We'll talk about this in a bit. Divide this by ab. So when you are dividing a number by a fraction, what you're really doing is you're multiplying it by the denominator. So 27 divided by 1/3, or if you want the long way, 27 divided by 1/3. Well, first thing you do is over 1, and you multiply it by the reciprocal. So 27, you would change this part to 27 over 1, change 1 over 3 to 3 over 1. Division is just the reciprocal of multiplication. 27 times 3 is 81. 1 times 1 is 1. 81 over 1 is just 81. So that's what I put. This whole thing is 81. I think it's much easier just to say, hey, what's the, I just multiply by 3 because it's 1 over 3. So that's 81 equals, the a's cancel out. I got 5 b's, 1 b, that is 4. 81 equals b to the 4th. I need to take the 4th root. You can just do that in your calculator. That will be b equals 3. I have my b value. Now I have to find my a value. Right, we could try to put this here or here. Well, I kind of don't want to. Fractions are kind of annoying me, so why don't I try this one? So 27 equals AB. Instead of B, I put 3 to the 5th. 3 to the 5th, if you put that in your calculator, I actually don't know that one. Is it 243? Oh, it is 243. So 27 equals A times 243. Again, I'm trying to solve for the A. What do I get? Divide out the 243. Divide out the 243. Cancel this. 27. So A equals 27 over 243. Okay. It looks like not using the fraction has made it worse. No, what's kind of nice is the calculator has a wonderful function that will actually change your fractions into reduced ones. So first you put 27 divided by 243. That turns into decimal point 1111111. But if you change it back to a fraction by pressing math, fract, it will give you the fraction in a reduced format. Oh, so cool. A is actually 1 over 9. So it's not this hideous one. It's still bad, but not as bad. So it's actually 1 over 9. So this is the one I prefer using. All right, I have my A value. I have my B value. All right, let's finally put it into equation. Y equals 1 over 9, 3 to the x. It may have been actually easier to use the first one. Okay, remember, just smart. This is your answer, not everything else. That's just the work. You could probably stop the video now. I really don't like this next question, but just to finish it, I'll finish it. So since 1910, human population has been exponential, and by plotting a growth curve, scientists are in a better position to predict and plan the future. So we're going to assume that 1910 is your starting point. Don't actually use 1920, otherwise your calculator will not actually be able to handle it. So 1920, how many years is that after 1910? That's 10 years after 1910. And the population was 1.75 billion. Next one. In 2010, that's 100 years after 1910. Population was 6.87 billion. So again, this is writing two equations using y equals ab to the x, and then dividing them out. Again, these are decimals. These are really not going to come out nicely. A lot of you will have probably significantly different answers from me. All right, I've lost my train of thought. Okay, 1.75, because that's the y value, equals a b to the 10th. What about this one? 6.87 equals ab to the 100th. This is going to be disgusting. Take the bigger equation, divide it by the smaller one. Let's move it up so I get a little bit more space. 6.87 equals AB to the 100th. I'm going to divide it by this equation here, 1.75. AB to the 10th. That looks like Greek letter sigma. There we go. 6.875 divided by 1.75. I did this already. You get 3.926 equals. The a's cancel out. Awesome. Remember, subtract the exponents. 100. There's 100 on top. There's 10 on the bottom. 10 cancel it all together. That is b to the 90. This is where I don't like the problem here. You need to take the 90th root. So, as weird as this is, go take the 90th root of both. Take the 90th root. The 90 and the 90 cancel out, and then you get some pretty crazy number. 90th root. What does that look like? So, math, go down to the 5. All right, replace answer with the 90th root. And put in, what is it again? 3.926. It's probably going to be 1 point crazy something. Yeah, 1.015. I'll round to 1.015. But because the numbers are so large and the root is so large, this is probably, in my opinion, this is probably going to be an extremely inaccurate equation. All right. I have my b value. Plug it into the easier equation. Nope. 1.75 equals a times b, which is 1.015 to the power of x, which would be 10. So I'm just plugging it into this first equation right here, that one. All right. 1.05 to the 10. It's going to give you a long decimal, which I just rounded again. 1.161. Again, just rounded. Okay, great. How do I do it? I divide 1.161 divided by 1.161. Just cancel out. A equals 1.507. So your final glorious equation, is y equals 1.507 to the 1.015 to the power of x. Again, I consider this equation really inaccurate. I don't like this problem very much. Yeah, that's it. Cool.